Hello, good evening, everyone. Today we are going to discuss this smoke test you may have tried. We will solve the questions from this mock questions. Okay, mock quiz. Have you guys attended this mock?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay.
Yes,
Then we will go one by one. So I think everyone's doubt will get covered from there. Fine.
Yes, ma'am.
Yes, ma'am.
Fine. Okay. So the first question uh, is it visible, right?
Yes.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. Let's start then. Yeah. So the first question is, suppose your x is a Bernoulli random variable with probability 1 by 3, y is Bernoulli with probability 1 by 2, and z is Bernoulli with probability 2 by 3. And if joint probability of xyz at a point 0, 0, 1 is given 1 by 4, and conditional probability that fz of 0 given that y is equal to 1 is 1 by 3, then find the value of conditional probability of fx at 0 and y is equal to 0 and z is equal to 1. So did you guys try it? How
Yes,
to
ma'am. Tried, but
okay,
couldn't solve.
okay. So okay, we will solve it. So yeah, you can speak, unmute and give your ideas. Okay. So this is question number 1. Right. So your x is a Bernoulli with what's your p here? 1 by 3, right?
1 by
And
3,
Yes.
y is Bernoulli with
1 by 2.
do you understand what this 1 by 3, 1 by 2 means here?
Yes, ma'am.
yes,
Probability.
Okay.
Probability
Probability
of
of success.
success.
Yeah, probability of success. This is 2 by 3. Okay. So for if I am writing here for x will take value 0 and 1, right? Because
Yes.
it's a Bernoulli, so it will have only two outcomes, right? 0 for the success, 1 for the 0 for the failure. This is general notation, that's why we write it like that, okay? And 1 for the success, right?
Yes.
And probability at 0 is what? And probability at 1 is what?
Probability at 0 is
0 is
2
3
by
by
3.
2.
is
2
by
Is it
3.
3 by 2?
Yeah,
2 by
2
3.
by 3.
2 by 3.
For x it is, okay? 1 minus 1 by 3, that is 2 by 3. And for probability that x is taking value is 1 by 3, okay? Similarly, if I write probability for y is equal to 0, then what it will be? 1 by 2, right? And what will be the probability at y is equal to 1? Again 1 by 2, right? And probability at z is equal to 0 will be, yeah,
1 by 3.
1 by
1
3.
1
by
by
3.
3.
Yeah, probability at z is equal to 1 will be 2 by 3.
2 by 3.
Fine. So what's given there? What do we need to calculate? Fx given that y is equal to 0 and z is equal to 1, right? At a point 0
Yes.
is the question. Then you know the formula for this conditional probability, yeah?
Yes, ma'am.
Yes,
Okay.
ma'am.
According to formula,
Joint
what
upon
do you yeah,
marginal.
it's joint upon marginal. Joint PMF,
Yes, ma'am.
Yes, ma'am.
joint PDF of what? Fxyz at a point 0, 0, 1,
0.
right? Divided by
Yes, ma'am.
Yes. YZ.
marginal PMF of yz at a point 0, 1, right?
0, 1.
So is any information given here
Yes, ma'am.
We
or
have
Joint.
given
anything missing?
Joint PM.
FXYZ.
Yeah,
Joint
this
is
one is
given.
given. Okay, this one is not given. So how to reach to this point? So
We
you
can.
have,
Probability of y is equal to 0 we have and z is equal to 1 we have.
yeah, fy at 0 and z is equal to 1. Yeah, y is equal to 0 and z is equal to 1 you have, right?
Yes,
So
ma'am.
you can go like that. Fyz at 0, 1 will be what? Can
1
anyone?
upon 4.
1 upon 4.
Yes, ma'am.
Is it so? Just check it
1
once.
Yes.
upon 3.
No,
1
ma'am. 1
upon 3
upon
or 1
4.
upon 4?
1 upon 4, ma'am.
Okay, just check it. Whether your PDF joint PDF is correct or not, there is a simple way to check it. How to check it? Let's say for YZ we are calculating. Let's say for Y and Z we are making the joint PDF table. Okay. So what the values Y can attain? 0 and 1, right? What Z can take? 0 and 1. So just calculate about the whole table. It's less than a minute task, right? So you want joint probability at 0, 0. What it will be? Just take Y at 0, Z at 0. 1 by 6, right? Are you
Ma'am,
getting
but
me?
they
Yes,
are not
ma'am.
independent. No?
Sorry?
Ma'am, but Y and Z are not independent.
Not independent, right? Then in that case, how see, these are the Bernoulli, and okay, they are not independent. You are saying, but
Yes.
still we can go like that. Why? Because if your toss Y, let's say it's a tossing or something, which is taking, if Y is taking value 0, then there is no restriction on Z taking 0 or 1. Is it there
Ma'am,
No,
for
ma'am.
particular Y?
event can be anything, not just tossing the coin.
Yeah, event can be anything. Okay. So
So
in
it
that
can
case,
be independent or non-independent both.
yes, you're right.
Ma'am,
Then,
but we have been given a value f of z
mhm,
given f of z equals 0 given that y equals 1. So
yeah,
how can we use that?
yeah, which one? Fz given y is equal to
1.
1. Yeah,
Yeah,
it is
fz is
given 1
equal
by some what?
There is a no use of this
No use
question.
of it actually.
Yes, ma'am.
No use of this information, in particular this question. But yeah,
Useless.
is 1 by 3. So just check it. From this information is like giving you something else. Just check
Ma'am, we can
the hmm,
use it as a marginal of
yeah.
conditional probability.
To just clarify that whether you can do here for to calculate fzy at 0, 0. To calculate this, can you do this one fz of 0 into fy of 0? To clarify this information will be helpful to you. Just check it. Fz given that y is equal to 1 at a point 0 is equal to 1 by 3. Okay. Just elaborate it what it is. It is fyz at a point 1 comma 0, right? Divided by
yes,
fy at 1, isn't it? This is equal to
yes,
Yes,
1
ma'am.
by 3. Okay. Now you know fy of 1, right?
Yes.
So
Yes.
I can just write it fy of 1, 1 comma 0 is equal to fy of 1 into 1 by 3. Now just check what is fz of 0. So even though they have not directly said that it's independent or not, but one of the thing they have given like that. So by this thing we can directly take a hint and can calculate fyz at 0. What we need 0 comma 1 we are seeking for, right? We are
Okay,
seeking
understood.
for fyz at 0 comma 1.
Yes,
Fine.
ma'am.
So for that we will use fy 0 comma 1, which is nothing but fy of 0 into fz of 1, which is what?
1
Fy
by
of
2
0
into
is
2 by
what?
3.
1 by 2 into 2 by 3, which is 1 by 3.
Yes.
Okay. So yeah, just to come to here. Now we know this fy of z also and fxyz also, right? Just put this value and we are done.
1 upon 4
Yeah, 1
upon
upon
1
4
upon 3
upon 1 upon 3,
1
which
upon
is equal
3
to 3 by
0.75.
4. Yeah, 0.75. Okay. So yeah, this
Yes, ma'am.
table was to inform you. Just you know that if you find the joint PDF for each and every value, then how will you check whether your PDF is correct or not? Then just sum up all these things, all these 4 probabilities. If they sum to 1, that means your PDF is correct. Otherwise, you have to check again. Okay.
Ma'am, if we go for this the joint probability table,
Yeah.
for each of the value it will be 1 by 4, right?
No. How it will be 1 by 4? Your y and z are the Bernoulli, but their these probabilities are not same. So it will not be 1 by 4. For y, the probability of success is 1 by 2. For z, probability of success is 2 by 3. Let's calculate it. What will get f00? What will you get? Fyz at 0, 0. So probability that y taking 0 is 1 by 2, z taking 0 is 1 by 3. So what's your probability then? 1 by 6, right?
Yeah, correct.
Yeah. What will be here? Fy of z at 1 comma 0. So we just calculated. It was given, right? Yeah. So y taking 1 and z taking 0. This one 1 by 2, 1 by again 1 by 6.
Third one also will be 1 by 6. 1 by 6, 1 by 6.
Now z taking 1. Z taking 1 is 2 by 3. So it's 2 by 6, 2 by 6. Okay. So just take your sum is going to 1 by 1. Yeah, 1, 2, and 4, 6. Okay.
Ma'am, I have a question here.
Yeah.
Here y and z are independent, but if we can we say all the three random variables are independent, x, y, and z, or not?
X, Y, and Z. No. No, we can't say.
Okay, because x, y, z is not equal to fx into xy into fz. That's why.
Yeah, is it so? Like.
Yes, ma'am. It's
Yeah.
Equality
yes.
is not true.
The numerator, how it comes 1 by 4? Yeah, 1 by 4.
How did you come for 1 by 4? Yeah.
Yeah, f x y z. How it came 1 by 4?
It was given there, no? In the question itself, it is given there.
Oh.
That was the given data for you.
Okay, only f z, y z 0 1 we have to calculate. That was simple.
Yeah.
Okay. Ma'am, how the denominator was calculated? Can you say once again?
Yeah.
If we go by both
approach, one.
Both approach is correct, no? Both approach is correct, right?
Yeah. Which both of these means? Which one?
How denominator 1 by 3 was calculated?
Okay, denominator 1 by 3. You want fyz at 0, 1. So just take the given information. Z at y is equal to 1. This was given, right? This part was given. From this part, you just got to know that, okay, it's an independent, y and z are independent. So you just went for fyz at a point 0, 1, which is just a multiplication of fy at 0 into fz of 1. So you just multiplied the things and 1 by 3 came here.
Ma'am, I have a doubt.
Yeah.
Ma'am, checking one combination is enough to prove that it is independent? Because here only one combination is given.
Yeah, it's not enough.
But how can we decide it is independent then?
It's not enough, but as in the question, nothing was given about the context, so we are taking the hint from it that it might be independent.
Okay.
Yeah, but that's a valid question. By checking the one combination, you can't claim that your random variables are independent. Okay, that was the hint actually, to just go for this fyz at 0, 1. Otherwise, they should describe the question in the way that they are independent, right? Okay. So should we go to second one?
Yes, ma'am.
Okay. Yeah. Fair six-sided die is marked 1 on one side, 2 on two side, 2 of its side, 3 on remaining three faces. The die is thrown twice. Let the random variable x denote the number obtained on the first row, and let the random variable y denote the number obtained on the second row. And z is a random variable which is defined as x plus y. So what can be the range of z? So yeah.
Ma'am, here all are the independent, na?
in this question number 2?
Yes, ma'am.
Yeah. Yeah, because it was a fair die. Okay. First thing, it is
Yes,
a
ma'am.
fair die, and they like they thrown it independently, like because have not defined anything that if your first die is giving 1, then what should be the outcome for the second one.
Yes, ma'am.
Okay, so X is what?
Ma'am,
Yeah.
1 to 3.
Ma'am, 1 minute, ma'am. How it is independent, ma'am? X is the number obtained from the first throw.
Yeah.
Y is the number obtained on the second throw.
Second
So
throw.
so 1, 1 will be 0, right, for me?
Yeah. 1, 1 will be 0. That means why?
Yeah.
See.
I got 1 on the first throw. There is only 1 ones with me. That face has only 1 1. So second time in the second throw, I will not get 1, right?
First throw you will get what?
1.
1. Okay. In the second throw, why you will not get 1? You can get, na? See, you are throwing the dice, right? Which has 6 sides. Now, let's say you thrown for the first time, right? And you got 1. And now, when you throw again for the second time, then the face that has 1 will not be removed from the die, right?
Oh, okay, got it, ma'am. I confused. Okay.
Second throw. Okay. So, the question here is, what will be the range for Z is equal to X plus Y? Okay. So, yeah, what should it be?
2 to 6.
2, 3, 4, 5, 6.
2, 3, 4, 5, 6.
Okay. For the X, range will be 1, 2, 3, right? And for Y, it will be again 1, 2, 3. Yeah. So, range for the Z is just sum of all this, right? 1 plus 1 and all this. So, is there any doubt for this range? Anyone?
No, ma'am.
Okay, fine. So, the next question is about
Probability of Z is equal to 3.
yeah, probability that what's the probability that Z is taking value 3? So yeah, just calculate it. What should it be?
1 to
1 by
9.
9. 1 by 9.
1 by 9. How it came? So
1 to 1 and 2 or 2 and 1.
yeah. So we need probability Z is equal to 3. That is when will we get the Z is equal to 3?
1,
For
2,
all the pairs 1, 2,
2, 1.
2, 1.
2,
Anything else? No.
No, ma'am.
that's all.
Right. Now, how did you came for the probability of this thing? Probability of 1, 2 and 2, 1?
1 is 1 by 6 and 2 is 2
They
by 6.
1 by
No.
6 and
Yeah.
How, ma'am?
Yeah,
1 by
6.
6.
Yeah, that's why I'm explaining. Probability at Z is equal to 3 is that means your outcome is this one. So how should I explain it? That means probability that your X is taking value 1 and Y is taking value 2, right? Or
ma'am,
probability
this
that
one,
X is taking, yeah.
if we think this way, that 1 we have marked as 1, 2 and 3 we have marked as 2, and 4, 5, 6 we have marked as 3, then all of their individual probability was 1 by 6. Now for 2 it will be 1 by 6 into 1 by 6.
Okay.
I mean, just thinking that way. So
See, they in the question they have said that one face is marked as 1, right?
correct.
One
So
face is marked as 1. 2 of its face is marked as 2.
yeah.
So it should be
So-
2 by 6, no? 1 by 6 into 1 by 6.
So what
1
I'm
by
saying
6
is
plus
1, it's 1 by 6 plus 1 by 6.
no, in their individual probability it is multiplication, and both side it should be plus.
Yeah. Now
Yes,
just check your dice. How your dice is formed is there is a one side with having 1 as one of its side, right? So what's the probability that your dice is, let's say X is the number, okay, in the die. What is the probability that your
1
die
by
will,
6.
1 by
it will
6.
be 1 by 6. How 1 by 6 came?
Total 6 and 1 of
Yeah,
that.
possible. This is total outcomes and this is favorable outcomes, right?
Right.
Now, your dice is designed so that two faces of the die are having number 2, right, on it. That
Right.
means probability that X is taking 2 is what? How many favorable outcomes are there for the
That-
die, 6-sided die?
2.
That it will appear 2. It's 2 by 6, right?
Yes.
For 3.
Right.
What is the probability that your die is landing on 3?
3
How
by
many
6.
favorable outcomes are there?
3 by
3
6.
favorable, yeah. So 3 by 6. Now just come to here. Say we know that X and Y are independent random variable. So probability that your X is taking 1 and Y is taking 2 is, yeah, Px1 into Py of 2, right?
Yes.
Yeah. And what it will be then?
18.
Yeah.
1 by 6 into 2 by 6.
Yeah, 1 by 6
Can you
into
please explain Px is equal to
1 by 6 into 2 by 6.
Px is equal to 2 by 6.
And
The second.
whole into 2.
Okay. What's your question? How this Px, this 2 by
Is
6
equal
came,
to-
right?
Yeah.
Okay. See, your dice is designed so that out of the 6 face, one face has 1 on it, right? And 2
Yes.
faces have 2 on it. A die has 6 faces, out of which one has 1 on it. 2 faces have 2 written on it, and 3 faces have 3 on it, right? So this is what written on your die. Fine. So
Okay,
I'm
I thought
asking
it's
you.
1 to 6 because generally in the die 1 to
Generally, it's in that like 1 to 6, but they have mentioned the question that your dice is designed so that, okay?
This is a biased dice, no?
No, this is not biased. How can you claim that they are biased? They have said it's a fair six-sided die. When they use the word fair, that means it's unbiased. Okay, fair die, fair coin, or anything. This is just a die. This is just like dice is what? It's a six-sided cube, right? It's like cube-like thing which has 6 faces, right? So it's
I was
saying that
thinking
yes.
Yeah.
A probability of coming this 3 is more than it is biased. Like
No.
Yeah.
Okay.
Biased. Biased means like probability of getting one face again and again. Like say if they have numbered all these faces as 1 to 6 and probability of getting 3 is highest when they have marked each side as a different number. And we are getting one number again and again. At that time we will say okay, it's a biased die. Like they will mention it whether it's biased or not. Okay. So yeah, the person who was asking that how probability that X is equal to 2 is 2 by 6, is it clear to you? This is your sample space and
Yes.
now I am
Yeah, it's
defining.
clear to me.
Yeah, okay. So yeah, let's come back to the question. So yeah, probability that X taking 2, and again what will be the probability here?
2 by
2
6
by
into
6
1 by
into
6.
1 by 6. So it's what?
4 by 36.
4 by
4 by 36, that is 1 by 9. Okay.
1 by 9.
Okay.
We have used function, right? The thing mentioned on second week.
Sorry, which function?
We have used the function that are mentioned on second week, right? The plus, minus, maximum, minimum. This is one of them, right?
Yeah. It's a sum of random variable. Yeah, it's again a function. Okay. So what's the next question then?
Are we solving all or we are solving by
Yeah.
doubt basis?
We are solving all.
Okay, so then next is Z is equal to 3.
Yeah.
Probability of Z is equal to 3 in that previous one.
We calculated that. See, we just calculated probability that Z is taking 1. That's 1 by 9.
Sorry, right. That is
Yeah.
right.
So now the next question is, box contain 7 milk chocolates and 3 dark chocolates. 2 chocolates are drawn at random, one after another without replacement from the box. Let a random variable x denote the number of milk chocolates drawn. What is the PMF of x? Okay.
Hypergeometric, na?
How it's hypergeometric?
No, it is a combination, no? That
Yeah, simple
7,
combination.
yeah, simple combination.
I am solving by the hypergeometric formula, and the answer is correct.
Okay. 7 milk chocolates. Okay. How did you claim that it's a hypergeometric?
Because it's dependent.
Yes, ma'am.
Yeah,
Because
two
it's
possible,
dependent.
yeah, 2 possible cases and no without replacement.
Fine. So let's go by the easy way, like here. That's not like needed that you have to recall the particular distribution, but if you have a case, then it's good. Yeah. So 7 milk chocolate and 3 dark chocolate, and what's the probability that what we need? How many dark milk chocolates?
So total 2.
Yeah, number of milk chocolates. If we are drawing 2 chocolates out of them, out of this 10, then what's the probability? What is the number possible numbers that number of milk chocolates can take?
10C2.
0, 1.
0, 1, and 2.
0, 1, 2.
Yeah, 0, 1, and 2. So let's calculate the probability then. So your x can take values 0, 1, and 2, right?
Yes.
Because we are drawing
Yes.
only 2 chocolates out of them. Okay. So yeah, what will be the probability for x taking these values? X taking 0, that means number
3
of...
by 10 into 2 by 10, 9.
Yeah, can you please repeat? Yeah, first how
3
many?
by 10.
3 by 10.
7,
LIC is 0.
3C2, right?
Yeah. Out of the 7 milk chocolates, we are getting 0 milk chocolates multiplied by this out of 3. We will select 2, right? Divided by 10C2, right?
10C2.
Yeah. Similarly, for the probability x is equal to 1, should I write directly here? It will be 7C1. Out of this 7, they are selecting 1 milk chocolate and 1 dark chocolate, right? Divided by 10C2. Yeah, what will be the calculation here? Yeah, anyone?
So first
1 by 15.
By 15.
1 and then 3 into, yeah, okay.
Yeah,
1 by
just a
15.
calculation. Let's calculate this one. So yeah, 7C0, how will it is 1, right?
Yeah, it is
7C0.
1
Okay.
into 3.
What about 3C2? It's 3 factorial into factorial, 1 factorial, right? Divided by 10C2. 8 factorial, 2 factorial. So yeah, it's nothing but 3 by 10 multiplied by 9. That means 45, right?
Yeah.
9 into 5 will remain. Is it fine? Okay. Should not like. It's a 10 into 9 by 2. Fine. So it's again 3 by 45. That means 1 by 15. Fine.
Ma'am,
Right.
I have doubt.
Yeah.
Can we not do it like when we are doing 1 by 1, means without replacement? Then we will always choosing like first case we are choosing from 3 dark chocolate, 3 by 10 into 2 by 9.
3 by 10 into 2 by 9 then.
No,
3 by 10. What? Just a minute. Yeah, please repeat. 3 by 10.
3 by 10.
0.
Okay, that means you are saying, okay, 0 milk chocolate. That means out of this remaining 3 dark chocolate, you are selecting 2 chocolates. That means first you chose 1 chocolate from the dark chocolate, that is 3 by 10. And then you are choosing 2 by 9. Why it's not correct? Okay. Yeah, anyone will answer it?
It's correct. It gives the same
It
answer.
is giving answer actually, but
Yeah, it's
is
giving
it wrong?
answer, but it's correct or not?
It's giving correct answer 1 by 15.
Yeah, yeah, it
It is
will give.
correct.
The matter
But-
is it is right or wrong.
Okay. What about the second one? If you want to calculate this probability that one milk chocolate is selected at that time, will it give?
There will be
Didn't give
two
one.
cases, so we have to multiply it by 2.
What are those?
Either first will be dark chocolate, second will be milk chocolate, and either
Yes, ma'am.
first will be milk or second will be dark.
Yeah, if you are doing like that, then you are correct.
Yeah.
Yes, ma'am.
Okay.
That's the same case.
Yeah. If you are doing like that, that x is equal to 1, that means you are selecting one milk chocolate. That means your first chocolate, let's say, your first chocolate is milk chocolate. So 7
Yes,
by 10, right? Multiplied by, you will go with the
3
second
by
one.
9.
That second chocolate should be a dark chocolate. That
Yes.
will give you 3 by
9.
9, right? And then you have to add the another case, another scenario that
That's
your
just
first
multiple.
chocolate is, yeah, first selected chocolate is dark chocolate, and the second one is milk chocolate. Okay. Sorry,
Yes.
7 by 9.
Ma'am,
7
we
by
have
9.
already removed in the first instance chocolates, so we still have to divide by 10 and 9 or
See,
the
this
other
addition
values?
is OR condition.
No,
This
no.
addition,
We are dividing 7 by 10. So in the first instance itself, we have removed the two chocolates. Okay.
one
So
chocolate.
in the second instance, no, in the first instance, we have removed two dark chocolates.
No,
Because
it's
of
taking 1
0.
by 1,
No,
ma'am.
no, no.
That's
This
why.
7 by 10, that means you have selected one chocolate. 7 by 10 is the probability that out of 10 chocolate, what's the probability that you will get a milk chocolate? Yeah, milk chocolate. So what's the probability? If you have a 10 chocolate, out of which 7 are milk and 3 are dark chocolate, then the question is just simple, that what is the probability that you will get a milk chocolate? That will be 7 by 10, right?
Okay.
Favorable outcome divided by possible outcome. So if you are going like that, then just consider the case that you have to consider all the possible cases. This is like what sequence wise you have to go, that what's your first outcome and what's there when you are drawing the second chocolate or second thing. Okay.
Okay. Got it.
So then in that case it is correct. Again, for probability x is equal to 2, that means 2 milk chocolates are drawn. At that time, what will you do?
7 by 10.
7 by 10 into 6 by 9.
9.
Okay, fine.
What is the better approach? Like which approach will be less error prone?
Both are the less error prone, but when you will calculate this probability x is equal to 1, at that time you have to be careful that you have to consider both the cases, otherwise you will get the wrong answer. But on the safer side, when there is you use combination kind of thing, then you are on the safer side.
Yeah, I think the first approach are less error prone actually.
Yeah. You will get like better answer with this, because you do not have to take care which chocolate was taken first or which was drawn second, right? Order doesn't matter here when you are going through these things.
Yeah, okay, right.
Okay, so should we complete the table?
Yes, ma'am.
Yeah, so for the first one, we have calculated it was 1 by 15, because again at the end we have to check whether our PMF is correct or not, right? What about probability at x is equal to 1?
7 by 10.
Yeah. Probability that your x is taking 1, that means 7C1. Again, out of 3 dark chocolate, you are taking one, selecting one chocolate, and rest is 10C2. Yeah. What will be?
So
it's a 7 factorial 6. So 7C1 is nothing but 7, right?
Yeah, right.
Yes.
And what about 3C1? It again
3.
Divided by, this was 9 into 5. 45. So directly it's 7 by 15. What about probability that your x is taking value 2?
Yeah, same. It is 7 by 15.
7C2, 3C0, right? 2 milk chocolate and 0 dark chocolate. 10C2. Yeah. 7C2 is what? 7 into
21.
yeah, 7 into 6 by 2 factorial, isn't it?
Yeah, that is
Okay.
correct.
What
Yes,
about
ma'am.
10C2? 10 into 9 by 2. Yeah.
This is again 45.
So again 7 by 15, right?
Right.
Okay. So just check it whether your PMF is correct or not. How to check it?
All should be 1.
All should
Yeah, all
sum together to 1.
It's sum to 1. So see, 7 plus 7, 14 plus 1, 15. Yeah. Right?
Yeah, yes, right.
So okay, it's a PMF.
Ma'am, I just have one doubt in that dice problem. Just wanted to know, everywhere we have to use the addition, right? No multiplication is there in the question number 2, right?
Where here?
In the question number 2, where we are marking the dice with.
Yeah, it is one. No.
Yeah, in that there is no multiplication, right? Everywhere we are doing the addition only, right? Within their own and then with the both combination. See, when we are getting that, what is the probability of that? Scroll down, like there. Yeah, here 2 by 6
Here.
we are getting from addition, and 1 by 6 all addition we are doing. We are not doing.
These are.
Yeah. There and here, right side also. All the places we are doing addition, right?
Yeah, here. Why we did addition here?
Because there it is their joint probability, right? I mean,
see, it's this term 1 is joint probability, term 2 is again a joint probability, but why addition is here? Do you have logic for that? See, we want to calculate what's the probability that your Z will take value 3, right?
yeah, Z will take
for
3.
For that, two possibilities are there. Either your X will take 1, that means in the first throw you got 1 and second throw you got 2. Or there is a possibility that on your first throw you will get 2 and on your second throw you will get 1. So these are two possibilities, either this one or this two or this one, right? So that's why whenever there are OR condition, we add it. We add all the possibility. That's why we are adding here. Okay.
So it is
because it was OR condition here. Now come to this one. Why we added here? Yeah, it was a fair die. First thing, it was a fair die. That means probability of getting any face is 1 by 6. Okay.
Right.
Probability that any face will appear is 1 by 6. Okay. Now your faces are marked as 1, 2, 2, 3, 3, and 3. Now you are asking what's the probability that your like die is landed with 2. Okay. That means probability of getting 2. So first is the possibility with these 2. So that's what how you calculate probability at 2. Just a simple thing. Favorable outcome divided by total, like all the outcomes, right? So what's the favorable outcomes?
2 divided by 6.
Yeah, so that's why total outcomes are 6 and favorable outcomes are 2. This first 2 and this one is second 2. Okay, that's why it was 2 by 6. That is again 1 by 6 or 1 by 6. That means either this face or this face, right?
Right.
So die. So there are two faces with having number 2. So either the first phase which has 2 or the second phase which has 2. So that's why it's 1 by 6 plus 1 by 6. Okay.
I got it.
Yeah.
Hello.
Yes.
Ma'am, can we do this question by making cases?
Question by?
By making cases.
You are not clear. Can you write on the chat? Or voice is not clear.
Yeah, no doubt. I think we can proceed to the next question. So there, the doubt was, I mean, I get it. It is all conditions everywhere you are doing the addition operation of their individual probability.
Yeah, fine. What that person was saying. Just a minute. You just write on the chat. I will check it out. Yeah. So
Yes, answer will be what? We have calculated everything. Then what is the answer? Yeah, okay. Yeah, this we
yeah, this one
calculated.
1 by 15, 7 by 15, 7 by 15.
Okay, whole is
Okay.
the answer.
So now next question, what is find the expected value of x. Okay, once you know the what are the possible values for x, and again you know the PMF of each values, then can you count or calculate expectation of x in that case?
Yes, ma'am.
Okay, how will it work?
Value into probability and then addition.
Yeah, summation xi into probability of xi. So yeah, let's do it fast. Yeah, first xi will be 0, right?
0.
0 into 1 by 15 plus, yeah, another xi possibility 1 into 7 by 15 plus again 2 into 7
2
by 15.
into 7 by 15.
Okay, so it's nothing but 7 plus 14.
21 by 15.
21 by 15.
21 by 15. Fine. That's nothing but 7 by 3. Okay. Fine.
Excuse me, ma'am.
1.4.
Yeah.
Ma'am, for question number 4, what if the question was with replacement?
Without replacement.
No, with replacement. What if it was with
What
replacement?
if it? Okay. What if it? Okay.
Yeah,
In
how
that
would
case,
we?
yeah.
7 by 5.
Yeah, how will we find the probability for those?
Okay. If the question was with replacement, what do you mean by with replacement? That means there are 10 chocolates, okay, and out of that 10 chocolates, you selected one chocolate, okay. You selected one chocolate, that is, let's say, milk chocolate, okay. So what's the probability that out of 10 chocolate you are selecting a milk chocolate? Yeah, what will be the probability? 7 by 10, right? In that
Yes,
case, the probability will be 7 by 10. Now, you are selecting 2 chocolates with replacement. That means now you selected one, now put it back, and now again you are selecting the another chocolate. So what will be the probability that you are getting the milk chocolate?
Again,
7 by 10.
7 by 10. Yeah. So in this way it will work. 7 by 10 into 7 by 10. Then in that case, probability that x is taking value, this will be the probability of what? Yeah, 2, 0 or 1?
This for 2.
This was for 2, yeah? Yeah. What will be the probability for x is equal to 0?
3 by 10, 3 by 10.
3 by 10 square, right? What will be the probability for x is equal to 1?
3 by 10 into 7 by 10.
3 by 10 into 7 by 10, okay? So yeah, in this way. Okay?
Ma'am, in third condition,
Mm-hmm.
shall we go for adding 3 by 10 into 7 by 10 plus first milk or second black, and like that we got to do that?
No, no need, because in that case, whether you choose first as a milk or second as a dark doesn't make sense, right? Because the probability will remain the same, 3 by 10, 3 by 10. Like, probability of getting the dark chocolate will always be 3 by 10, right? Because you are replacing the chocolates. So just check whether this PMF is correct or not if you are selecting the chocolate with replacement.
So order does not matter if it is with replacement.
Yeah.
But the ma'am, sum of the PMF is not coming to 1.
Not coming to 1.
Yeah.
Why it is?
Maybe we have to multiply 2 in the x equal to 1 thing.
Because of this one. Because of this one. Why? Now if I add one more thing here, 7 by
21 by
10
100.
square, then what
Yes,
will
ma'am.
happen?
That condition I was talking for.
Yeah, it's needed. Because we are going like, what do we say?
Whether we are selecting dark one first or whether we are selecting, okay.
Yeah. In that case, it will matter. Now check it whether it's summing to 1 or not.
Yes, ma'am. Now it sums to 1.
Yeah. Okay. Fine. Is it clear to everyone?
Yes.
Okay.
Yes, ma'am.
Yeah. Okay. So let's move to the next one. Okay. The joint PMI of two discrete random variables x and y is given like that, and find the value of covariance of xy. So that's pretty much easy, right? You have PMF table, you have joint distribution for all of this, and you just have to calculate covariance of xy. So yeah, let's do it.
Here, ma'am, x and y are independent random variables. That's why covariance is 0.
That's why covariance is 0.
Yes, ma'am.
Okay. Have you checked whether they are independent or not?
Yeah, yes, ma'am. I've checked it from the table.
You checked it from the table.
Yes, ma'am.
Okay.
Yes, joined by marginal is equal to conditional
Okay, yeah.
for all the cases.
For all the cases, then you directly say that yeah, it's a covariance as a 0. So have you checked for all the condition effects
yes,
of
yes, ma'am. For all the conditions?
For all the conditions. Okay, let me check once. Or let's say if you don't know whether it's independent or not, let's say they are not independent. In that case, how will you calculate covariance of xy?
Then we have to find E of x, exy.
Variance of x into variance of y.
Okay.
No, expectation of y minus expectation of x into expectation of y.
That's the same for variance of x into variance of y, no?
No, why you have to, I mean, I get confused. Why you have to go in the first approach? No, right? We can apply the formula and get the covariance, right?
Yeah, but when it is independent, then we don't need to go into the calculation.
No. See, the thing is, we do the calculation. We will not know whether you will come to a conclusion that dependent or independent. If it is dependent, then you will have to again calculate the covariance, right?
That is actually waste of time, finally.
Yeah. If it is dependent, then it's like choice. Sometimes when you practice it, by just observing the values, you will just it's easy to check whether they are independent or not. Just take it's not that much time taking if you check it whether it's independent or not. Both the ways are like short and simple only.
Ma'am.
Yeah.
Ma'am.
Hello.
Like I did not know if this was independent. Ma'am, in the first, I did not know if it was independent. I had to check if it is summing up to 1. The probabilities, if it is summing up to 1, then it is independent, right?
No. Probabilities are summing up to 1. That means the whatever the table is, the probabilities are correct. That means this joint PMF is correct. That will give you this information only.
Okay. So, ma'am, how
To
do you
check?
decide if
Yeah.
it is independent?
Yeah. I'm telling you.
Also, ma'am, if we calculate the covariance, why are we?
Yeah.
Why aren't we getting 0? Ma'am, like if we calculate it.
It is 0.
If you are calculating it, yeah, just one by one, speak one by one. Yeah, go ahead.
We calculated it in a way like, ma'am, can you go back to the table?
Yeah.
In the lecture, sir has given an example like that. So I did it in that way. It is quicker.
Correct. It is giving 0.
Yeah, it will give you 0. Yeah. In table what?
Ma'am, like 0 into 0 into 1 by 12, 0 into 1 into 1 by 6, plus 1 into 0. We can eliminate
why
the
you are
0.
using into?
No. We first
That expectation of xy.
And
Yeah.
product of
Like in
marginals
also
equal to.
lecture video, sir had done like that.
Ma'am, what
No,
she is
no,
telling,
no, no.
what she is
No.
telling is she is applying the covariance formula. That is E of xy minus E of x into E of y. That's what she is doing.
Yeah. I understood. But like one way is that. Another way is you can just directly do this calculation also. That is also not tricky. Expectation of x and expectation of y and expectation of xy. Isn't it? Or one thing is just
She is
let
telling
me
this
just
only, ma'am. This what you
yeah,
have written. No, she is telling
she
this.
was going with this thing. Now I will tell you how someone can directly say the covariance is 0 by looking at the table. Okay, this calculation Like do anyone have doubt for this calculation?
Yes, ma'am. Ma'am, can you just explain how to calculate expectation of xy?
Okay. Let me just draw the table first so that both of the thing we can discuss here. Yeah. What are the values for x? 0 and 1. For y, we have 0, 1,
0, 1.
and okay. So it's for 0, 0, it's 1 by 12, 1 by 6. Yeah.
1 by 6.
1 by 3.
3. And
1 by 12.
1 by 12.
1 by 6. Fine.
Yes.
Okay. So this is your table. From this table, you can just, is it easy to calculate marginal PMF?
Yes, ma'am.
If you know this one, yeah.
Yes, ma'am.
Then let's do it. See, I will just take all the denominator as 12, okay? So the
Yes.
calculation will be quite easier. So it's 1 by 12 and it will be 2 by 12, right?
Yes.
So your
Yes, ma'am.
marginal is 3 by 12 for this one, yeah. This is 2 by 12, this is 4 by 12, 6 by 12. Is it fine for everyone, or should I should not do that?
Yes, ma'am. Fine.
Yes,
Yeah.
ma'am.
Fine, ma'am.
Okay.
3 by 2.
Yeah. So yeah, for the last one again 3 by 12, right? Yeah. Here what it will be?
4 by 2.
1, 2, and 2. Yeah, 4. And here it will be
8 by 2.
8 by 12. Okay, fine. Once you know the marginal PMF, joint PMF, it's very easy whether your X and Y are independent or not. How to check that?
Multiply the corresponding.
Yeah, multiply by the corresponding. So, if you multiply, you want to know whether your X and Y are independent or not. So, yeah. What's the rule? That your fxy at let's say point T1 and T2 should be equal to what?
Fx of
1 into
T1.
FF T2.
Fx of T1 into
Fy of T2.
Fx of T, Fy of T2.
Okay. So just check whether your F00 is equal
Yes,
to
ma'am.
Fy of 0 into F2 of 0. Just check it. So it's you will get what? It's 1 by 12, right? Let's check fxy of 0, comma 0. What is it? Fx of 0 into Fy of 0, right? That's what? 4 by 12 into 3 by 12. And once you calculate it, it's 1 by 12. Okay, this is way to check whether your X and Y are independent or not. But note one thing, you have to check it for each and every joint PMF. Okay, your joint PMF should be equal to product of the marginal PMF. Okay, you have to do this thing for all these 6 values. If you are getting your X and Y are independent, okay, if your if your fxy of T1 T2 is equal to fx of T1 into fy of T1 for all the values of T1 and T2, for all T1 and T2, then your X and Y will be independent, right? Or independent, and once
Yes.
they are independent, then you can use argument that X and Y are independent, so your covariance will be 0. Y will be equal to 0. Now, this is one method where you have to check all these 6 quantities, whether they are giving you the product of marginal or not. And the second one is the classical way where you just have to calculate expectation of xy minus expectation of x into expectation of y. Now,
Y.
can you just tell me expectation of x and expectation of y? This you can calculate, right?
Yes, ma'am.
What about xy? What now? X is a random variable, y is a random variable, so xy is right. Now, once xy is random variable, what are the possibilities that your xy will take? Let's say
0,
or
1,
z is equal to x. Yeah, it will take
0,
0,
1,
1, 2.
one. When it will take 2? Yeah, it will take 0, 1, and 2. Now you have these probabilities, and you know that your product can take either value 0, 1, or 2. Fine. So what's the probability that your xy is taking value 0?
1 by
Whenever
2.
your whenever
1
your xy pair will be like 0, 0,
X is
1,
0
3,
or Y is 0.
yeah, or 0, 1 or 0, 2, right? X is 0, Y is 2.
Ma'am,
Right? Is it fine?
we can simply calculate the marginals from the table.
Yeah, you have to calculate marginal from table only.
Yeah.
But for that you should know that, right? You have to add all these probability, all these 4 probabilities.
Yeah, ma'am, by the marginalization.
Yeah. By the margin, yeah. So 0, 0, 0, 1, 1, 0 and 2, 0. You just have to add all these conditions and you will get, what?
3.
For this
1 by 2,
problem
ma'am.
that Z is taking 0 is 3 by 12.
Yeah, 1 by 2.
Yeah. It will be 2 plus 1 by 2. Fine. When will it take Z is equal to 1? So in one case only, that is 1, 1, right?
Yes, ma'am.
So the probability for 1, 1 is
1 by 3.
Yeah, 1 by 3, and probability for 2 is 1 by 6. Okay. 1 by 3 and probability that Z taking value 2 is 1 by 6. Now, you know all the values and you know their corresponding PMF also. So you can calculate expectation also. Okay. So should I go for the calculation or next question?
Ma'am, can you go to the previous method that you did?
This one.
Yeah.
Independence.
Here 4 by 12 into 3 by 12. How do we get 1 by 12?
4 by 12 into 3 by 12. It's a 12 by 144. It's see 4 into 4 3 is 12 divided
yeah,
by
yes,
1
yes.
by 12.
I got
Yeah.
it.
Okay. So what are the calculation for expectation of xy? Yes. If you go for the expectation of xy, what will be the value? It's a 0 and here 1 by 3 plus 2 by 6, right?
It's 2 by 3.
Isn't it?
1
Yeah.
by 3 is 2 by 6.
Okay.
2 by 3.
Expectation of xy will be, first for the 0, that's a 0 into 1 by 2 plus 1 into 1 by 3 plus 2 into 1 by 6, right? So it's 2 by 3. Is it?
2 by, yeah, correct.
Okay. What will be the expectation of x?
1 only.
Your x is taking value 0 and 1, right? So 0 into 4 by 12 and plus 8 into 12 by plus 1 into 8 by 12, right? Is it?
Right.
Oh, fine. What about expectation of y? So it will be 0 into 3 by 12 plus 1 into, what are the values? 6 by 12.
6 by 2.
Yeah, 6 by 12 plus 2 into
3 by 2.
3 by 12.
Ma'am,
So, yeah.
ma'am, for expectation of x, we need to calculate only second column. Na?
Not second column, the marginal PMF. Marginal PMF for x at 0, fx at 0 is 4 by 12. This one. The last row.
Yes, ma'am.
Ma'am,
we can also calculate expectation of x by calculating second column.
Which second column?
Because first one is 0, na?
Are you talking about this one? This
Yes,
second
ma'am.
column? No, this is joint PMF. You can't use for calculating the margin. Yeah.
Ma'am, 1 by 6 plus 1 by 3 plus 1 by 6.
Why it is so? Why? How it will make sense? Your expectation of x is what? Summation of all the xi's into fx of xi's, right? This fx. Yeah.
Ma'am, in this case, why he is getting that? Because one of the value of x is equal to 0, so that part is becoming 0. And
Yeah.
anyway, we have calculated the marginal of x1. So he is thinking that way, that it is, but it is wrong.
Yeah, that's like what we say coincidence. What if the values of x will be 1 and 2? Then this is not the case, right? You have to go with the marginalization only. The formula for the expectation is xi into fxi. Here the margin, like your x is taking value 0. That's why when 0 multiply with this 4 by 12, that is sum of all these things. Sum of all these things is 4 by 12, right? So
Yes, ma'am.
0 is multiplying with this, so it's becoming 0. What if your random variable had range 1 and 2? At that time, this will be not 0, right?
So, ma'am, we can add both the columns, no?
Yeah. We have not added the column. We have like multiplied the number that your random variable is taking with its marginal PMF and added all this thing. Added all the possible values of random variable and its PMF.
Ma'am, instant 0. There is any other value?
What?
Any? I'm
Yeah,
just.
go with Hindi.
Yes, ma'am.
You can speak in Hindi.
Okay, ma'am. Ma'am, like 0 की जगह पे कोई और वैल्यू होती है यहाँ पे. तो हमें ना 4 by 12 into that value plus 1 by 1 into plus 1 into 8 by 12 करना पड़ता ना.
Yes, correct. Yes. That's why I'm for, like pressurizing on this point that you have to go with this thing only. Once you like elaborate this thing, this is nothing but x1 into your marginal PMF for the value x1. X1 is what? These values. What your random variables are taking, 0, 1 or 2 or whatever it is. Plus x2 into fx of x2. So in this particular case, your x1 is 0, so this term became 0. If this x1 was not 0, at that time this was a non-zero number, right? That's why I am stopping you to just calculate with the column number 2. Okay. Fine. So once we have calculated all these expectations of x, y, and xy, what's your answer here? Covariance for xy?
Expectation of xy minus expectation of x into.
Yeah. What was
Expectation
expectation
of
for
y.
x? 8 by 12 into expectation of y.
It is 1.
So it's a 1. Yeah. So yeah, it is 0. Okay. So
Yes,
these
ma'am.
were the two methods. Whichever method you are finding easy, you can go with that. If it's very easy to observe, if your random variables are independent, then don't go for the calculation. Directly make it 0. Yeah.
Ma'am, can you explain question number 16?
Yeah, we are going one by one all the questions. We are taking all the questions.
Okay, ma'am.
Okay. So next question is we have given a function which is having PDF like this, and yeah, what's the value for C? Yeah, how will you go for it?
We have to integrate in the range and is equal to 1 summation of.
Okay, so how will be the integration?
In
2 parts.
Piecewise, yeah.
In 2 parts.
Integration of cx square from 1 to 2 plus integration of cx from 2 to 4 is equal to 1.
Fx dx should be equal to 1, right?
Yes, ma'am.
That's
Yes,
what you
ma'am.
will do, 0 to infinity. But here it will be integration
Piecewise
1 to 2
continuous.
1 to 2 cx square.
Yeah. Cx square dx plus yeah, next one will be 2 to 4, right?
Dx,
Yes, ma'am. Cx.
What's it, 2 to 4, right?
Cx.
Cx dx and
is equal
rest
to
part
1.
is 0. Yeah, so you have to just integrate and find the value of x. Is it fine for you?
Yes, ma'am.
Should I leave here?
Yes, ma'am. Yes, ma'am. Leave.
So yeah,
Can you calculate the answer? Because my answer is quite different.
0.12, I think if that is not different, 0.12 will come. Correct is
You have to
1.
just integrate.
Yeah.
Simple integration, not a very much stuff.
Yeah, that's why I left it, but let me just complete it. Okay, so how will you go for cx square? C is common, and x square integration for
X
x
cube
square is
upon
x
3.
cubed by 3. Taking value 1 and 2. Again, C common.
X
What
square
is this?
upon 2.
Yeah, x square by 2, which is taking value 2 and 4 is equal to 1. Yeah. Now C common. Yeah.
8 upon 3 minus
8
1
by
upon
3
3.
minus 1 by 3. Sorry.
Then
1 by 3 plus 16
16
by
upon 2.
2 minus 4 by 2,
4 by 2.
which is equal to 1. Yeah. So yeah, again
7 upon
once
3
you solve it,
plus
8 minus 1 is 7 by 3 plus 16
plus
minus
6.
4 is 12 by 2,
6. Yes,
which is equal to 1. Yeah. Yeah. So just go for it. 7
Yes, ma'am.
into
You can
14
leave it
plus.
25 upon 7. 25
So, yeah.
upon 3.
Yeah, sorry. 14 plus 36 by 6, which is equal to 1. Again, your C is
3 by
6 by
25.
yeah, what?
3 by
3 by
25.
25. Yeah,
Yes, ma'am.
3 by 25. Fine. And once
Yes, ma'am.
you have calculator, right, in exam?
Yes, ma'am.
Okay. Okay. So there are some 16 questions there. Therefore, I am like leaving some easy questions, which are just
Yes,
a calculation part.
Ma'am,
Yeah.
ma'am, can you solve an example for double integration? Ma'am,
Which one? Like, is there like double integration? Is there in your like? Do you came across that in this particular quiz?
no, ma'am. Ma'am, I solved. I did a previous question paper.
Okay.
So there is a question.
I think it
Okay,
is
okay,
not
okay.
there,
Like,
but not sure.
Ma'am,
see,
can we do this question paper first and then move to outside the question paper?
That's what my like target is.
Yes,
Let's
ma'am.
first finish this smoke discussion.
Thank you,
Then,
ma'am.
if time permits, then we will go for the rest of the parts. Okay,
Okay,
so this particular question is the PMF is given to you in this format, and then you have to calculate the joint PMF. So this is again one of the simple question. Yeah, how to do this? So just put the values, right? Isn't it? So
Just
in
X
your
and Y.
question number 8, your what fx of fxy is given, right? So y of x comma y is given as 1 by 27 twice x plus y. Is this correct? Like, this is the function, right? If I am not wrong.
Yes, ma'am.
And your x and y are taking the values from
0, 1.
1, 2.
1, 2, sorry. 1.
yeah 0, 1 and 2. Okay, and 0 otherwise. So like how your joint PDF table will look like. Your x and y values are like that.
3 by 3.
Yeah, 3 by 3. 0, 1, and your 2. These are the values for x, and these are the values for y. Fine. So 1 by 27 is common to everyone, right? So like for 0, 0, how will we go? 1 by 27, 0 plus 0, isn't it? You have to put x, like x is equal to 0 and y is equal to 0. Now, x is 1 and y is 0. So, how will it be? 1 by 27, x is 0 plus y is 1, right? Sorry, y is 0 here. So, it will be 2
2
plus
by
0?
27.
0.
2 plus 0, yeah, 2 by 27. And what here? 4 plus 0, right? Is everyone getting it? Like what I'm doing here? Now just addition part is there, like 2 by 27, 4 by 27. Here it is 0, right? What about here? Your x is taking 0 and y is taking value 1.
1 by 27.
Yeah. Here, when both are 1, 1, that is 2
1,
plus
1.
1. Yeah. 2 plus 1, right? 1 by 27. Here it is 4 plus 1. And what about 2 and 0? 0 plus
0
2.
plus 2.
Yeah.
2 plus 2.
So just take it whether it's giving you correct answer or not.
Ma'am, 2 plus 2, no?
Yeah.
Then 4 plus 2.
1 by 4 plus 2. Yeah. Just take it whether it's giving correct or not. So just add all the numerator. If it sums to 27, then you are correct. Otherwise, wrong. So this one is 0, right? Yeah. 2 plus 4, 6, and 1, 7, and 3, 10, 15, and 2, 17, 17 and 4, 21, and 27, right? Is it correct?
Yes, ma'am.
Okay. So that was the question for, this was the question, right? We have to just calculate what's your
Yes.
PMF table is. Okay. Moving to the next one.
How 2 by 0 comes?
Sorry? How?
In the
Can,
table which you showed, in the table which you were calculating, sorry. No, in the solution.
okay. We will go to that question. Let's go for the question number 9, where we have to calculate probability that x plus y is less or equal to 2, given that probability x is already greater than 0. Fine.
This one I got 0.33, but the correct answer start range is 0.35.
For question number 9.
Yeah, yes.
Okay. First, let me clear this doubt. What was your doubt? Yeah, please. Someone was asking with this table, right? Question from this table. What happened?
Ma'am, yeah, 2 plus 2. No, in the solution. Yeah. 2 plus 0, how it came? In 0 row, first of all.
This one?
0, y, x is equal to 1, x is
This
equal
one?
to 1, y is equal to 2. Yes.
Yeah, your x is 1 and y is 2. And the function for your PDF is 1 by 27,
2x plus
twice
1.
x plus y. So 2, yeah, okay. Fine.
Okay.
So yeah, probability that your x plus y is greater or equal to 2, given that x is greater than 0. So first we will take, first you will explain it, expand it, how it will be. It's a conditional probability, right?
Ma'am, it's probably x plus y
greater
less
or
than equal
2.
to 2, ma'am.
Sorry? It's less or equal to 2?
Yes.
Okay, thanks. Yeah, so your probability that x plus y is less or equal to 2 and x is greater than 0, right? Divided by probability that x is greater than 0. Okay, what do you mean by probability x greater than 0? First, let's complete this part. Probability that x is greater than 0. That means what?
2. 1 and 2.
Probability that x is equal to
So
1. Yeah.
1 and 2 addition.
Yeah, you have to just calculate the marginal PMF for x is equal to 1 and x is equal to 2. That means, let's calculate the marginal PMF for all the x. What it will be? Yeah, for x is equal to 0, it will be 1 and 2. That is 3 by 27, right?
3 by 27, 9 by 27, 15 by 27.
Okay. 9 by 27 and
15 by 27.
15 by 27. Okay. So probability that x is greater than 0 is what? 9 by 27 plus 15 by 27, right?
Yes, ma'am.
That's what? 24 by 27.
24 upon 27.
Okay. What about this x plus y greater or equal to Now you need to calculate this probability when x plus y is less or equal to 2 and x is also greater than 0. That means your sum should add up to 2 only, but just take care that your x can take either value 1 or 2 only, right? Not
So
0.
T of x is equal to 1 and 2. T of y is equal to 0, 1, 2.
Yeah.
0, 1, 1, 1, 1, 0.
Sorry. Yeah. That
Range
means
of x and y will be 0, 1, 1, 0, 1, 1.
yeah. So probability of, let's say, 1 0, will it work? 1 and 0, the
Yes,
sum
ma'am.
will be
1,
1.
0, 2, 0, 1, 1.
1 0 2 0 and
1, 1.
1 1. Yeah. Just take
0,
care
1.
that your sum should not exceed 2.
Ma'am, 0, 1 is also.
0, 1 also.
Yeah. 0 1 also. Yeah. 0 1 and 1 1 also, right?
Yes, ma'am.
No.
Yes, ma'am.
Not
1 1.
x is greater than 0.
0,
Yeah.
1.
That's why this 0 1 will not be there because your x should
Yes.
be greater than 0. Yeah. Okay. So only these possibilities, these three, or anything. Not
1, 1,
possible, right?
1, 1, 1, yeah.
Yeah, I am just writing it. Okay, so only these three, right? So do you know the probabilities for all these things? Probability of x,
Yes,
y,
yes. 2
taking
by
all
20.
these value. So just
Ma'am, we have to
yeah,
take the common now. Ma'am, we have to take the common in total 4. Hence, the probability of 0, 1 we have to take now.
no.
The
See,
numerator.
probability of x, y taking 0, 1 you can't take. Why you can't take? Because the given condition
Conditional.
is your x is greater than 0 and x plus y should sum up to 2. So this condition is satisfied by 0 1, but x is not greater than 0 when you are considering 0 and 1.
But
So
ma'am, we have to take the common in between both now, and we have to
not
total is 4.
how a common in between both, that means your range should start from the the range of x should start the values greater than 0 only. So when you are
Yes.
the point where you are considering 0, that's not in this set. The set contains all the possible values where sum should not exceed 2 and range of x should be greater than 0. So in that case, the set which will satisfy all two condition is these three conditions only. That means your xy taking value 1 0, here x is greater than 1 and sum is 1, right?
Okay,
Again
ma'am.
2
Got it.
0. Yeah.
Yes, ma'am. Got it.
Okay. So what is the probability that your x plus y is less or equal to 2 and x is greater than 0 in that case? Sum of all these three, right? Joint probability.
Yes, ma'am.
fxy 1 0. Yeah, what is that? Can you just calculate it?
4 by 27. Next one is okay. Sorry.
Yeah. So 4 by 27 is sum or the one value?
No. The total is 0.33. Addition of all these three is giving
Ma'am, we
0.33.
have to take. Ma'am, we have to take joint na. Joint probability na.
Yes, joint probability fxy taking 1 0. What's that value? 1 0. 2 by 27, right?
Yes.
From
4
the
by
previous.
27.
What about
1 by
fxy taking 2 0? 4 by 27?
4 by 27.
What about 1 1?
3 by 27.
3 by 27. Okay, fine. So you just added 9 by 27, right?
Yes, ma'am.
So what will be the
Divide.
required? Yeah.
Divide.
What was being asked to you? The conditional probability that the sum should not exceed 2 and x is greater than 0. So it is 9 by 27 upon what? We have
24
calculated
by
it, right?
20. Yeah.
What was that? Yeah, 24 by 27, right? Right? 24 by 27. So it's what? 9 by 24, nothing but the 3 by 8.
Yes, ma'am.
Okay. So it will sum up what's your answer? 0.375. Yeah. Who calculated? Like someone has doubt here, right?
Yeah, ma'am,
Is it clear?
I missed it in the calculation. Everything was fine, but I missed to divide it by the marginal.
Oh. Okay. Just be careful while doing such a kind of calculations. Otherwise, you have conceptual clarity, but due to the calculation mistake, you will lose the marks, right? Okay. So question number 10. An unbiased coin is tossed 3 times independently. X represents the number of heads, Y represents number of tails in first 2 tosses. Define another random variable u is equal to xy, and you have to calculate PMF of u. So here you have to note one thing, that first calculate what are the possible values for u. So they have done the toss for 3 times, right? And it's an unbiased coin. That means probability of head and tail will be 1/2. So
Yes,
your
ma'am.
x is number of heads. What is the range for x?
0, 1, 0, 1, 2.
0, 1, 2, 3.
1, 2, and 3 also. 3.
Yes,
3.
ma'am.
Okay. Toss a coin 3 times. Okay.
And for
Ma'am,
y, it
2
will be
times.
0, 1, 2.
No, 3 times.
No, 3
Read the
times.
question. It's a they have
Okay.
3 times independently. And y is the number of tails in first 2
tosses.
0, 1, 2.
0, 1, 2.
tosses. Yeah. So for your y, the range will be 0, 1, and 2. So if one define the random variable u as product of x and y, then what will be the range for u?
0, 1, 2.
0, 1, and 2 only, right?
Yes, ma'am.
Okay. When will it be 0?
0, 2.
Yeah. 0 will be
0 will be x and 2 will be y.
0, 0. Okay. For this particular, you have to define your set, right?
Yes, ma'am.
Outcomes. Since it is a coin only, you know all the 8 possibilities, right?
Yes.
So
Ma'am, before
let's-
that, can you explain once range of y?
range of y. Okay.
It's asking for only 2 now.
Number
2
of
tosses.
tails in first 2 tosses. That means when you toss a coin 3 times, that means your outcome will be in the format 1, 2, and 3. Like this, your outcome will be, let's say, H, and H. Okay. So y in this particular case, this H, what is your x? Yeah.
3.
X is 3. Y is what? Number of tails in
0.
first 2 tosses. In your first 2 tosses, you have to check whether there is a tail or not. So it's in this particular case, y is 0. But if I change the question like TT, H, and not TTT, let's say, then what's your x? What's your y?
X0, T
And y?
T2, Y2.
Okay.
Y2. Clear,
Okay.
ma'am.
Did you get? Okay. Even though your number of tails are 3, but you have to count first 2 tosses. Okay. Fine.
Yes, ma'am.
So, yeah. What are the all possible outcomes when you toss a coin 3 times?
HHH, HHT, HTH, TTT.
Okay. Fine. It will be like, okay, I'm just writing if okay.
TTT.
K, TDT, T, HT, sorry, HH, and T,
TH.
TH. Fine. So just calculate when your U is 0. The U is 0 when X is 0 or Y is 0, right? Either you have a number of, what are the possible cases when your U will take 0? That means either your X is 0 or Y is 0, right? So what are
Yes.
the outcomes when U is taking 0 for, yeah?
0.
Yeah.
TTT.
0, 2.
TTT, is it fine?
Yes, ma'am.
Okay. Any other case? No, right?
HHT.
Yeah, H.
Okay.
Yeah, which one?
H.
Okay, in this case, your Y is 0, right? And other
THT.
THT will not work. HHT will.
HHT.
Yeah, it will work. Fine. Any other case? No, I think. When you will take 1.
1. Sorry. THT. HTT.
And HTT. Here your Y is 1 and X is also 1, right? When U will be 2. So yeah, remaining cases, this is 3 plus 2. Okay, 3 should be there. Yeah, THH will work. Number of heads 2. Number of tails in first case is 1, right?
HTH.
TTH.
Yeah, and
TTH.
TTH. Okay, nothing is repeating, right? And nothing is missing also. Okay, fine. So these are all your possible outcomes, and since they are it's a fair die, your U is taking value 0, 1, and 2. So what's the probability?
Coin, right?
Yeah, it's a fair coin. So yeah, what are the probabilities then? PMFs?
3 by 8.
3 by 8.
2 by
2
8.
by 8. And again 3 by 8. Fine? Okay, any doubt?
Ma'am, why we are saying that range of U is equal to
0, 1, and 2.
Yeah.
Okay. U is what? U is a random variable which is nothing but the product of X and Y. Your X is taking value 0, 1, 2, and 3. Y is taking value 0, 1, and 2. Now you have to multiply among these elements. Okay. So what are the possibilities? You can multiply 0 with 0.
Only 1.
Right? 1 with 1. 1 into 1.
1.
You can multiply 2 and 2, 4. But in that case, if your X is taking value 2, is there chances that your Y also take value 2? X is what? Number of heads, right?
Number of head.
Okay. Let's say your number of heads are 2. That means you have possibility that 2 H's are there. Now you need Y as number of tail in first 2 tosses. It should also take 2. So that 2 into 2 you can multiply them, right?
Ma'am, is it TTHH? No.
TTHH, but this is not possible because you are tossing a
Yes,
coin only 3 times.
3. Yes, ma'am.
Okay. So that's how we are we are discriminating the value 4, right? Otherwise it's possible, right?
Yes, ma'am.
Because 2 into 2, 4 possible, 2 into 3, 5 possible, but they will not occur from the outcome itself. It's not possible to take values for you to take these values.
Yes,
right? Or you can confirm from
please
these set
explain
also. Yeah.
Ma'am, can you please explain the probability of the 0, 1, 2? I did not
This
get
probability of U taking 0.
Yes, ma'am.
Yeah.
Yes, ma'am.
So U is 0. That means what are the possible outcomes, favorable outcomes, whenever you will get U is equal to 0. Now you know that U is nothing but the product of X and Y, right?
Yes, ma'am.
So just check for this. Okay, I will explain you with this. See, these are the outcomes, right? When you toss a coin 3 times, right? Isn't it? These are the 8
Yes,
possibility you will get. Okay. So now you know that X is the number of heads. So just calculate X for all the cases. What is X here?
X3, 2,
Okay,
2,
let's
1.
just make a table only. That will be fine. These are the values for X, okay? And the next one is value for Y. Y is what? Number of tails.
Tosses in first 2 cases.
Okay. So what's your X here? 3. Here
2, 2,
1,
1.
Here
0,
it should be 0, right? 2
2,
and 1.
1.
right? What's the value of y? That means
0.
number of
Zero.
tails in first two. Yeah.
0, 0, 1.
1 again, right? HTT.
Yes, ma'am.
1.
Okay, number of tails in first two tosses. Again here.
1. 0. 2.
Number of tails, yeah.
2.
1.
1, 2.
This is
Number
one,
of tails.
one
Number of
and
tails.
2. 1 and 2.
Okay. So what's the product then? That's nothing but your u, right? U is equal
Yes.
to x into y. Just product it. 3 into 0. 2 into 0.
But
2
it
into
will take
1.
the
1 into...
all the cases.
Yeah.
In this we did not get the whole.
Sorry? It
In
will
a
not
simple.
take...
0, but we have to select the unique set here.
Yeah. So the unique, it will be unique only.
So 0,
See,
1 and
in
2.
this particular case, I have stressed much on your minds that how will you go that your value u will take 0. So here you first choose u has to take 0 and then you have to come out what are the possibilities. So this might be easy, I think, when you go with this, that if you toss a coin 3 times, these are the possibility, this is the value for x and this is the value for y. And this is for u. Now you want to calculate the probability that u is taking 0. Then what will you use? You use directly the formula favorable outcome by possible total outcomes, right? So yeah, probability that u is taking 0 is what? 1,
3 by
2,
8.
3 by 8. Okay, the person who was asking this question, is it clear to you how I am getting the probabilities here?
Yes, ma'am.
Okay, for probability u is taking value 1. How to go for it? The favorable outcomes are 2 only.
2 by 8.
2 by 8.
2 by 8. See, we have done the same thing here, 2 by 8, right? See, when we had u is equal to 1, have we considered these two cases only? HTT and THT, see? The same thing. Here we have calculated the value of u and now we are focusing on this fourth column and looking for the values of the probability, right? Yeah, for probability u is equal to 2.
2 by 8.
3 by 8. 3 cases, right? Okay. So is it clear now?
Yes, ma'am.
Okay. So yeah, what's the next one? Yeah, if the probability at u is equal to a, given that u greater or equal to 1 is 2 by 5, then find the value of a. Did you try this question?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Got the value for a?
Yes, ma'am.
Yes, ma'am.
Okay. Let's do it. Yeah. What's its probability that u is equal to a, right? Given that u is
2 by 5.
Greater than equal to 1.
Greater than what? Yeah, greater than
1 is equal to 2 by 5. Okay. So this is what, just write it. It's a conditional probability, right? Probability that u is equal to a and u is greater or equal to 1 divided by probability that u is greater or equal to 1. So greater or equal to 1 means 1 and 2, right? So that's 2 by 8 plus 3 by 8, isn't it?
Yes, ma'am.
So let's just, okay, is equal to a, okay, u greater or equal to 1. Yeah. Probability that u greater or equal to 1 is nothing but probability u is equal to 1 plus u is equal to 2. So you just add 8 plus 3 by 8, right? 5 by 8.
Yes.
Yeah, you just
And
put
you do
this
the
value
cross
as
multiply.
cross multiplication. U is equal to a, u is greater or equal to 1, which is equal to 2 by 5. Multiplying this value, probability u greater or equal to 1. Yeah. What it was, 2 by 5 into 5 by 8.
2 by 8.
So
1 by 4.
just go to your table which value is giving you 2 by 8. So this is nothing but u is equal to 1, right? Isn't it?
Yes, ma'am.
Which is equal to probability that u is equal to 1 implies that your value for A is 1.
Yes, ma'am.
Okay.
Please just scroll down.
Yeah. Yeah. Yes.
Okay, got it.
Okay, give me a minute, okay? Fine. What's the next one?
Ma'am, last one. How you compared it from table? I couldn't get that.
Okay. In the table, just find which value is giving you 2 by 8. Say our calculation ended up with the 2 by 8, right? And this is what probability of u taking value 1 whenever u is greater or equal to 1. So just check the table. Whenever u is greater or equal to 1, which PMF is giving you the value 2 by 8. So it was nothing but this u is equal to 1. Okay?
Yes, yes, ma'am. Thank you.
Okay. Yeah. For next one, yeah. What's there? A fair die is thrown 2 times independently. X1 is what? Number obtained in the first row. And X2 is the number obtained in second row. Define a new random variable X, which is max of X1 and X2. Okay. Then you have to compute CDF of X. Okay. Have you guys did this question?
Yes, ma'am. It will be k by 6 whole square.
Okay. Let's do it. So now it's a fair die and both the throws are independent of each other and they have given it, right? So can you just tell me what will be the joint PMF directly? If your X is number on the first number you got on the first row, right? What are the possible values that your X1 can take?
1, 2, 3, 4.
1 to 6.
Number on first row, let's say. And X2 is number on second row. So what are the possible values your X1 and X2 can take? X1 will take any value from 1 to 6, right? And what is the probability of getting any number?
1 by 6.
1 by 6 for both of them, right?
Yes.
So if I consider the pair X1 and X2, then what's the probability that any number can take? Now it's a now I am throwing 2 dice. So what will be the probability that X1 comma X2 is taking some value?
1 by 36.
1 by 6 into 1 by 6. Yeah, 1 by 36. Why 0? Someone told. For all X1 and X2, right?
Yes.
Okay. Now we have to define a random variable X, which is nothing but maximum of X1 and X2. So what will be the range for capital X? This new
1 to
random
6.
variable?
1 to 6, ma'am.
Again 1 to 6. Yeah. So here, if we make a table, PMF table, PDF table, how will it look like? X1 will be here, X2 will be here, right?
6 by 6.
Yeah, it's a 6 by 6 table. So I'm not drawing the complete one. 1, 2, 3, 4, 5, and 6. And just tell me what will be the joint PMF? Have we calculated
36.
it?
1 by 36.
1 by 36 for each and every value, right? Why it is
Yes,
so?
ma'am.
No.
Because all are independent.
All were independent, and you have used a fair
1 by
die,
12. Yes, ma'am.
right? 1 by 36 for all the values. So I am not writing it. Is it fine?
Yes.
1 by 36 for all the values. Okay. Oh, but there is a like something why I have written the table like that. Okay. So now let's calculate the PMF for your random variable x, which is maximum of x1 and x2. So its PMF will contain how many values?
6 values.
Yeah, 6 values. And what are their probabilities?
For 1, it will be 1 by 36. For 2, it will be 3 by 36.
Yeah.
And
Just
odd.
probability that x is equal to, yeah, probability x taking 1. That means what? Whenever your
1,
maximum of x1 and x2 is
Maximum
1.
of 1
From
and 1.
table, yeah. From table, it will be easy to check whenever your when your maximum of x1 and x2 is 1. So just consider these things. Whenever you consider all these cases where x1 is 1 and x2 is 1, at that time your maximum will be 1, right? And the probability for that is 1 by 36. Only one case was there. When what are the cases when your maximum of x1 x2 will be 2?
3 by 36.
1, 2, and 2, 1.
And 2, 2.
Yeah, to
And
consider
yes.
all the cases, the best way is to just make this kind of things. So how many cases are there? This 1, 2, and 3, right? So it will be 3 by 36. What about 3?
5 by 36.
How will you
5 by
calculate?
36.
Yeah, again the same thing.
5.
5 by 36. In each term, for each value, 2 will increase. Yeah. For
7
4,
upon
it will be 7 by 36. For 5, it will be 9 by 36. For 6, it will be 11 by 36. Okay.
Yes, ma'am.
So how to go for the CDF then? Should I write it like probability x CDF is nothing but x? Yeah. What do you mean by CDF of x? How to write
less
it?
than or equals to x.
X less or equal to small x. Okay. So while calculating CDF, you have to add all the previous probabilities to the corresponding one, right? So probability that x less or equal to 1 will be 1 by 36 itself. What about 2?
4 upon 36.
Yeah, 3 plus 1, 4 by 36.
Then 9
For
by
3, it will be
36.
4 plus 5, 9 by 36. 9
Then
plus 7,
16.
16 by 36,
Then
and
25.
25 by 36, and at the end 1, right? 36 by 36, 1. Okay. So yeah,
Yes, ma'am.
that's how we calculate the CDF.
And that max value, how you are coming to that? Can you please just explain that? Actually, I did not get that.
This one?
Ma'am, but in the answer is K in the terms of K.
What K? Yeah. Okay. Just a minute. If answer is in the terms of. Okay, let's first sort how we are coming with the maximum value, right?
Yeah, right.
So your maximum value can take 1, 2, 3. Is it okay? How the values are taking 1 to 6 values? Because your x1 can take either 1 to 6 any value. X2 can again take any value between 1 to 6.
Correct.
So whenever we are taking the maximum of 1 to 6 to 1 to 6, possibilities are 1, 2, 3, 4, 5, 6. Okay. So how to calculate when will your maximum will be 1? So from table it's easy. How? Because it's giving you kind of coordinate view, right? So just calculate. If you consider any case which will intersect this 1, 1. Why? Because in this range, if you take any value, any pair, that will give you maximum of 1, 1. So here at this particular point, what's your coordinates? 1, 1, right? Your x1 will take value 1, x2 will again take 1. So maximum of 1, 1 will be 1. Okay?
Okay.
For 2, that means you want your x is equal to maximum of x1, x2. It should give you value 2. Now, how to calculate the numbers? So, what are the possibilities when can your x can take 2 value 2, x1 and x2? If the value of x1 and x2 will exceed by 2, then maximum will not remain 2, right? So just make bounds for x1 and x2 both, that x1 should not increase by 2. So we will come up till let me change the color. Okay, so your x1 just bound it to the value 2. Just a minute. Okay, so your x1 just bound it to the value 2. So your x1 will not increase by this limit, okay? Because otherwise these are the values for x2. So if you go down by this, then your x2 will attain 3, right? But we want maximum as 2 only, so we will not go to 3. We will stop it here, where whenever your x2 is 2. Now come to the x1 part. Now just move till the point where your x1 cannot exceed value 3. So here your x1 is 1, no problem. X2 is 2, no problem. Okay. So these are the 3 cases where your x1 and x2 are taking values not exceeding 2. Okay. See here, what is the value? What's coordinate at this point, at this particular point? X1 is 2 and x2 is 1. And the maximum is 2, right? What are the values at this point? 2, 2. For this particular point?
For the first one, it is 1, 2.
Okay. So let's calculate whenever your maximum is 4, how to go it, how to go for that. So whenever I am traveling this side, that means I am ranging my value for x1, right? Because these are the values for x1, right? Horizontally.
Right.
Okay, let's move. So your x1 can take 1, no problem. It will not make your maximum less than 4 or greater than 4. Okay. Okay, you can have 3, you can have 4, you can't have 5. So I will stop here. Okay. Now for x2. So start with this one. So your x2 can take value 1, no problem. Can value 2, 3, 4. Again stop here. You can't go beyond 4. So these are all the possibilities where your maximum will give you 4. Is it? Are you getting this point?
Okay.
Ma'am, in case of minimum?
In case of minimum. So in minimum, how we go for the minimum? Your x1 and x2 should not exceed that point, right? Should not, yeah. For minimum, let's say you want your x1, minimum of x1 and x2 to be 1. Then how will you go? The direction will be reverse actually.
Yes.
See. Okay. Just change me the color. Okay. Let's say you want your minimum to be 1. Okay. So what are the possible cases when your minimum will be 1? So yeah. Okay. You have to direct like this. 1, 1. Okay, fine. You can have any values. Because why all these values are possible? Because your x2 is 1, right? So x1 has no limit. Whatever the x1 will take, the minimum is between x1 and x2. So your minimum, the value is 1 here. So whatever the value your x1 will take, that has no limitation because x2 is 1 here. Fine. Now go like this. Now fix x1 as 1, okay, and go like this. Let's give the x2 to take any value. Now the direction is reverse. That's all. For taking minimum as 2, you will be like, okay, let's fix x2 is equal to 1, and x1 can vary anything, because at the end we are taking minimum. Fine. And here again it will be like this one, okay, and so on. For 3 it will be like this, and so on. Okay. Otherwise, if you solve this question, you will get to notice one thing, that every time you are you have increased by plus 2. See, 1 plus 2 3 plus 2 5. Why it is so? Because whenever you increase your partition, it's just increased by 2 values only. That will come with the, what we say, experience. But just observation also you can feel. Okay, now you want this CDF in terms of k. So just note one thing, this 36 is common to all. Fine. So your
Yes, ma'am.
fx of x is 36 is common. Okay, just divide it by 36, no problem. Now just take one thing. Whenever your x is 1, your denominator, your numerator is 1. X is equal to 2, numerator 4. X is equal to 3, numerator 9. 4, 16, 5, 25. Is there any relation between these numbers?
Increasing by 2 in each step.
Ma'am, difference is in P.
Let's take x as a 1, and this is, let's say, I'm just taking some value.
Ma'am, square up the numbers.
Yeah, 1, 2. For 1 it's taking 1, 2 is taking 4, for 3 is taking 9, 4, 16, 5, 25. What are these pairs?
Squares of
These are squares of numbers. So whenever you are writing fx of x, let me make it k, so that there should not be any confusion. So whenever your fx of k, it's nothing but the k square, right? If you are taking 1, it's 1 square, it's 2, it's 2 square, 4. So this is how k square by 36 should be your
Yes, ma'am, got it.
option.
Yes, ma'am. Next question. Probability of x is equal
So yeah,
to
k
4.
by 6 the whole square is optional. Find the probability x is equal to 4. So this kind of questions we have done a lot, right?
Yes, ma'am.
So probability at x is equal to 4. How will you go for it?
1 4 4 1 and 4 4 will have.
Probability at x is equal to 4, you can directly give it, because we have made the PMF table first. So directly put x is equal to 4, it's 7 by 36. Isn't it?
Yes, ma'am.
Okay. So it's 7 by 36. Fine. What if you do not have this PMF table and they have given you directly CDF table? Okay. Directly CDF is given to you and this particular row is missing from this table, then how will you check what's the probability for x is equal to 4?
We can minus.
Just one doubt in the previous problem.
Yeah.
This one, when we are adding up, right? Just the concept wise, I'm trying to understand. So 136 plus 4 by 36, the value what we get, that we take. I mean, is it all adding up, or how the addition to be done?
See, whenever you are calculating CDF for, let's say, at a point x is equal to 3. So CDF says whenever you want to want CDF at a point 3, at that time you need to add all the probabilities that your random probability of all the events that your random variable has attained. So
Correct.
when you come to 3, what are the numbers your random variable has achieved? 1, 2, and 3, right? So you have to add PMF of x taking value 1, probability that x is taking value 2, probability that x is taking value 3. Probabilities, okay? These probabilities, not this one. Got it?
Yeah, so yeah, got it. So yeah, need to add the probability and then we
The probability of all the events that has occurred till the point x is equal to 3.
yeah, okay.
Okay. So yeah, probability at x is equal to 4 by using CDF only. So yeah, what are the values then? Probability x less or equal to 4 minus probability x less than 4. Fine. What? Yeah, probability x less or equal to 4 is
16 by 36.
and x less than 4?
9 by 36.
Okay, very good. Minus 9 by 36. Okay, this is again 7 by 36. Okay. Yeah. Then question number 14, right? 14. Yes. Suppose your x is a random variable which is following Poisson distribution, then find the value of lambda for which this condition is satisfied. Okay. How did you guys try this question?
Yes, ma'am.
Okay. So this is again a direct question, like. So yeah, just tell me how to do that.
Simply put the values in it was minus lambda power x upon x factorial and solve for lambda.
Yeah. So for that you should know the distribution for Poisson random variable, right? Or isn't it needed?
It is given in the question,
Yeah.
the quiz 1 paper.
Okay. So we need to calculate this probability. X is equal to 3 twice probability x is equal to 2 plus 4 times the probability x is equal to 1. Fine. So yeah. Yeah, what is the probability that your random variable x is taking value 3?
8 power minus lambda power 3
upon 3
by
factorial, right?
3 factorial.
Yeah. Similarly, you have to just put the values like that and calculate the value of lambda. Yeah. What was the value for lambda then?
4, ma'am.
4.
4. Ma'am, leave it, ma'am. We can solve further.
Okay. So yeah, lambda is here 4. Okay, you just try it by yourself. If there is any doubt, just ask me. Okay. So this question will reduce into quadratic equation and you will find the two values for lambda, but you are not considering the negative one. Why?
Because range is from 0 to infinity for Poisson.
And it's a Poisson random variable. The interval can't be negative. Okay, that's the definition part. Fifteenth one. Okay, there is an inequality. Find the lower bound for the. Okay, isn't it a direct question?
Yes, ma'am.
Minus
Yes,
per
ma'am.
sigma to x minus mu. Okay, what it should be?
It is plus
greater than or equal to 1 minus 1 by
1 minus 1
2
upon
sigma
k
less than
square.
equal to x.
Okay, then 1 minus the lower bound is in this this kind of inequality is 1 minus 1 by k square. What's your k?
K is 2, ma'am.
K is 2. Okay, that's right. Okay, should we move to the next one?
Yes, ma'am.
Yes,
Yeah,
ma'am.
this is somewhat interesting question, right? Yeah. So the graph of the probability density function
We have to
is
integrate in this question.
okay. Is the integration needed or you can directly go for
Not
it?
required,
ma'am,
ma'am.
not
Not
needed.
required.
Not
Simply
required,
getting
right?
the area.
Yeah.
Ma'am, please solve this question.
Yeah, I will solve. Okay. So the graph is given to you, and the first part is which of the following is true. Okay. So let me draw this. And then what's the next question? Let's check that also. Yeah, first you have to find the relation which is true, and the second one is probability that mod x is less than alpha by 2. Okay. Okay, so it's somewhat what 0, right? 0, and here it's, let's say, beta. Zero comma beta. It's alpha comma 0, and here it's what, minus alpha comma 0.
Minus alpha comma 0.
Okay. Okay, this is also a boundary of the your given area, right? And here it is somewhere here
Beta
at
by 2.
beta by 2, right? So yeah, this continuous line is your boundaries. Beta by 2. Okay. Fine. So you have to calculate what's the relation there. Okay. So how to find that relation, whether they are true or not? So
Find the area and equate it to 1.
Area of triangle minus
yeah.
This area of rectangle minus area of triangle is equal to 1.
Yeah, but for it's fine. I'm just explaining for all. See, whenever you have this kind of question and you have to find what the relation is to be followed by your graph or CD continuous function, then at that time you know one thing always about one thing always about your random variable, that it's if it's area, then area should add up to 1. Okay, so now the question arises, how will you calculate the area of this particular graph? So there are two ways. One way is you can find this equation for this line. That is also not that much difficult, because whenever you know this point, what's this point? Yeah, what are the coordinates for this particular points?
Minus alpha beta.
Minus alpha comma beta. What are the coordinates for this point?
Alpha beta.
Alpha beta. So you know this equation of this line. This is what? Yeah, this straight line, vertical line, x is equal to minus alpha, right?
Yes, ma'am.
What's the equation for this vertical line? X is equal to alpha. Now,
Yes.
do you know the equation for this line? Yes, you can know. How? See, you have two coordinates, minus alpha comma beta and 0 comma beta by 2. Now in your 10th, I don't know, 10th or 12th, you may have learned the equation of line passing through 2 points. So you can
Yes,
find the
ma'am.
equation of line for this and for this, both of them. The equation of straight line is y is equal to mx plus c, where m is slope and c is what? C is intercept. Okay.
Yes.
So this was a hint. If there are some random function which you do not know, then you can go like that. But in this particular question, it's quite easy. Why? Because you can just do the things like that. First of all, the note that this graph is symmetric graph. Okay, because here it's the length of this particular horizontal line is what, twice alpha. 0 to alpha, the difference here is alpha, again 0 to alpha. Now it's again divided at this point, which is beta by 2, and the same, and it's a symmetric graph. So I will do one thing. I will just give the name to each point. Let's say it's O, A, B, C, and D. Okay. Now, if I want to calculate the area of the whole, so I can do one thing. I will just calculate the area of O, A, B, and D and twice it. Is it fine? Can I do that?
Yes, ma'am, we can.
Actually, rectangle minus a triangle is also okay, no?
Yeah. So first, let me just, we are just going step by step. So I am taking like that. Okay. So your area, total area should be equal to 1. Why? Because the given graph is not a random graph. It's a distribution of some random variable, right? Which is continuous. So it's a total area should be equal to 1. And now if I say it's nothing but 2 into area of OABD, right?
Yes.
So this area of OABD is nothing but what? Area of your rectangle. What's rectangle there? OACD, right? CD plus area of triangle. What triangle is ABC. So yeah, what's the area of triangle OACD here? Area of
Hello,
rectangle is
ma'am.
length into breadth, right? So alpha
Alpha
by
into beta by
alpha
2.
into beta by 2. Alpha into beta by 2. What's the area of triangle? Half into a base into height, right? What's base? Alpha, height, beta by 2, isn't it? Right? What's
Yes,
the
ma'am.
base there? Alpha by 2. Sorry.
Alpha into beta by 2.
Alpha into beta by 2. Okay. So yeah, just go for the addition and yeah, we have what it will give.
Ma'am, just one doubt in this problem. If
Yeah.
you go to that little scroll little up, this one here, we know this is a triangle, right?
Yes.
So we know the what is the like base and height for this triangle. I'm saying that so
Yeah.
length and breadth is known for the triangle.
Yeah.
Then if we so there are like the upper portion of the triangle.
Mhm.
If we with the three, if when all the coordinates are known, there is a
Mhm.
formula that we can get the area under the triangle.
Yes. You
So
can go like that also.
so the entire area minus that area, and then the below portion is the our PDF, right?
Yeah,
That-
yeah.
Oh, okay.
Yeah, it's alpha comma beta by 2. So you know all the coordinate, you can go with that also. That's also fine. Okay. So was that your question?
Yeah, that was what I was asking. That
Okay.
basically the PDF given is that by taking out the upper triangle, the portion which is in the green line, this is our PDF, right?
Yeah.
Okay.
Okay. This sum should be yeah, this should be 1, right? By 4, this should be equal to 1. Now solve it. What are you getting here? So it's nothing but alpha beta plus alpha beta by 2, which is equal to 1. So it's nothing but 3 by 2, right? 3 by 2 alpha beta, which is equal to 1. That means alpha beta is equal to 2 by 3. So this is one of the option. So that's correct relation. Okay. So next question was question number 17 or 16. What it was? 17, I guess.
Sorry, ma'am. If
Yeah.
once we calculate the equations of the line, what we need to do, ma'am? This method I got, area I got, ma'am. But
Okay, with equation of line,
uh-huh.
which will be very difficult in this particular, like not difficult. Once you know the equation, you have to integrate via that.
Oh, so this okay, I got it. For each of these limits, okay, from minus
Yeah.
alpha to okay, I got it.
Minus alpha to 0. And like it's a kind of double integration, right? Integrate from minus alpha to 0, and one of the integration will be along the curve. Plus again integrate from 0 to alpha, and another will be your along the curve. That's what double integration will come into picture.
Okay, ma'am. This is
okay.
This area method.
This would be the easy one, because in this particular one you are able to divide it.
Ma'am, I have a question here.
Yeah.
Can you show me the picture? Can't we integrate, ma'am, only 0 to alpha and double it?
Yeah, possible. Yeah. Because it's a what we say. It's a symmetric one, so we can do that. Yeah.
But ma'am, function, what we use the function to integrate?
Function.
We'll
Yeah.
have to
Function is
equation of the straight line. We will have to calculate.
Yeah.
ma'am, to make the calculation more easier,
Yeah.
we can also, can you please show me? Okay.
Yeah.
2 alpha into beta, 2 alpha into beta minus
2 alpha into beta minus.
is 2 alpha
Okay, you are just
into beta by
subtracting
1 by 2.
the
Yes,
this
simply
area.
straight
Yeah,
line,
that
straight
is
line.
also, yeah, that's also the like that would be actually easy.
Easier.
Yeah. Like he's saying to calculate all the area, this all like of the rectangle, that's whose breadth is twice alpha,
Length
and
is 2 alpha
yeah,
and
twice
height
alpha,
is
and breadth is
beta
beta.
is the width.
Twice alpha beta will be your area of rectangle minus
that upper triangle.
Yeah, upper triangle, where height is beta by 2, and this base will be your twice alpha again. Yeah.
Yes.
That's also fine. And yeah, when you will integrate, your function will be the equation of line, and limit will be minus alpha to 0. I don't think so the double integration will come into picture. Or you can do it by double integration also, when in that case you need function that's missing here. Okay, so the last question, what it was, let me just check. It was probability of modulus x less than alpha by 2. Yeah. So probability modulus x less than alpha by 2. How to calculate this one? So modulus x less than alpha by 2. That means your x should lie
To
between.
find area between alpha by 2 and minus alpha by 2 and alpha by 2.
Yeah. Whenever your x lies between minus alpha by 2 and alpha by 2. Okay. So it will be somewhere here, minus alpha by 2. Say minus alpha by 2, and here. Okay. So we have to calculate in this particular case this area.
Plus alpha.
Yeah. Yeah.
The right side plus alpha.
Yeah. So now how to go with that?
First, we'll find the point beta there. I mean, what will be the point beta at that point, alpha by 2, on that line?
Okay. Just yeah.
Area of trapezium.
Sorry. So in this particular case also you can go with that easiest way with the rectangle thing minus the triangle. Just extend it, or the thing is you can find out this particular coordinate, which how will you find out this particular coordinate? This the red color. This one you know, right? Let's say
Yes, ma'am.
name it E. The point E, you know, that's nothing but alpha comma beta by 2.
Alpha by 2 comma beta by 2.
Yeah, alpha by 2 comma beta by 2. Yeah. This is alpha by 2 comma beta by 2. This is point E. The question is, how will you find this point? Once you know
Then
that,
by using the
Midpoint theorem,
linear
ma'am.
equation.
By midpoint theorem, ma'am, that will be the midpoint of the given.
but like, how can you claim that's the midpoint?
Then we can use the equation of line y minus beta by x minus alpha equal to beta minus beta by 2 by alpha minus 0.
Yeah.
Ma'am, I solve it for from the equation. I got the 0.3 beta by 4.
0.3 beta by 4. What's that?
3 beta by 4, ma'am.
Yeah. You solved it by
Equation.
equation, right? Yeah.
Yes.
That's also one of the ways. So this is nothing but, if I say, so it's twice area of yeah, what's your rectangle here? Let's say it is F. Okay, AE, no, AOEF, right? EFO plus area of triangle. What it was, AE. That point we have not defined. Let's say G. Is it okay? That the area probability is nothing but this area, right? So yeah, let's go with the first. Okay, what will be the area of this rectangle? Alpha by 2 into beta by 2, isn't it? Now the question is area of triangle AEG. So for that, let's suppose that the equation of that line is y is equal to mx plus c. Fine. So when x was equal to 0, your y was getting beta by 2, isn't it?
Yes.
So your c is nothing but beta by 2. Is it fine?
Yes, ma'am.
Okay. So another point you have is that oh yeah, this was this first point I used point A. Now use point B, which is alpha beta. So whenever your when your x was taking value alpha, your y was taking value beta. So equation will be beta is equal to mx, x is what? Alpha, plus your c is beta by 2, isn't it? That implies your m is what? Beta by 2, yeah, beta by twice alpha, isn't it? Is it fine? Now you know m and c both. So that equation of line is what? Y is equal to but we need point at, yeah. So now this is your equation for y is equal to beta by twice alpha x plus beta by 2. Okay, this is the equation of this line AB, right? This is equation of line AB.
Yes, ma'am.
Line AB. Now, do you know any point x or y there, or which point you don't know? You don't know this point y, right? X is equal to alpha by 2 at that particular point G. At G, your x is equal to alpha by 2, right? So what will be the value of y? Just put alpha by 2 here. Beta by twice alpha into alpha by 2 plus beta by 2, right? So yeah, it will be beta by 4 plus beta by 2, 3 beta by 4, right?
Yes.
Is it fine? Okay. 3 beta by 4. But we need, so y is, yeah, the point G is alpha by 2 comma 3 beta by 4. So 3 beta by 4 is the length of hole. We need
From G
area
to
of
F.
triangle AGE. So the height till height of EF is beta by 2. So just subtract it. That's the length for G, right?
Yes, that will be beta by 4.
So your area of triangle AGE will be 1 by 2 length of AE plus length of G. Sorry, not plus. Into length of EG, right? Yeah. So what's the length for AE? It's alpha by 2.
Yes, alpha
What's
by 2.
for EG? EG is 3 beta,
Beta by
by
4.
4 minus beta by 2. Is it fine?
Yes, ma'am.
Why I'm doing that? Okay. So it is alpha by 4 into this one is if I do beta by 4.
Beta by 4.
A product alpha by alpha beta, we know that, right? It was
Yes.
somewhere 2 by 3. So it's 2 by 3 multiplied by 4 into 4. Yeah. So by 2, 1 by 24. So this was area of triangle AGE. Now your probability, but we need probability that your x is lying between minus alpha by 2 plus alpha by 2. That's what twice of area of triangle, rectangle and area of this triangle. Yeah. What was that area? Alpha beta by, okay. So that was alpha beta by 4 plus this area of triangle AG, which is 1 by 24. Again, this alpha beta we know that is nothing but 2 by 3, right? Plus 1 by 24. Yeah. So again 2 into this 2 to the 4, 5 by 24 and nothing but 5 by 12. Is it okay?
Yes, ma'am.
Yeah. So that was your probability that your modulus x is less than alpha by 2.
Ma'am,
Yeah. Yes.
ma'am, can you scroll a bit up? Ma'am, towards where you are calculating area of triangle, second part. Yes, this
Area
one.
of triangle AEG.
Ma'am, how did you calculate beta by 2?
Yeah, this one.
Yeah.
This C is equal to beta 2. Just this.
No,
This
no.
is your equation of line, right?
No, ma'am. The
Then
area of rectangle first.
area of rectangle AEF beta by 2. This beta by 2. Okay.
AEFO, yes.
Yeah. So check. This is your rectangle AEFO, right? Base into height. So see, the length of A and O was given to you. That was beta by 2. From there, I got this beta by 2. And alpha by 2 is the length of O and F.
Ma'am,
Yeah.
I have to ask one thing. As I was saying earlier, ma'am, in triangle ABC, E is the midpoint.
ABCE is the midpoint, but how will you get to know
Yes,
that?
yes,
Okay,
ma'am.
E is the midpoint. That's not a
Yes,
problem.
ma'am.
Yeah.
Midpoint theorem says
Hmm.
a line passing through the midpoint of a triangle parallel to others bisects the third side.
Yeah.
In this, G is also a midpoint of AB. We can directly calculate these coordinates.
Yeah. That's also fine. But how did you get to know that this line is passing through a what we say center of the triangle?
Yes, ma'am. Here E is the midpoint. We have just
Yeah.
E is the
E is-
midpoint. EZ is parallel to BC. Then
It's parallel to BC. Yes. Yeah. You can go with that also. Yeah. Right.
And
Yeah.
in this way, simply
According to that, you can directly get that your
in
point
this
G is
way,
3 beta by 4. Yeah.
yes, ma'am. In this way, we can obviate the need of calculating the equation.
Yeah. Yes. Correct.
Ma'am, are we going to get such questions? They seems very time consuming and it would take like 5 to 10 minutes to complete. Just one question.
Okay. Let me just check what's the time. Okay, it's 8:30 already. Okay, that
No,
was
no,
the just a minute.
No, I was just asking
Yeah.
that if we are going to get such questions or not. This is quite time consuming, then we might lose a lot of time in exam while proceeding with such questions.
Yeah. So, like, what is there any other options? That is your question. Like, is see, this is not the only way by which you calculate
Ma'am, he
this
is
value.
asking whether we get questions or not.
Your voice is breaking.
Ma'am, he is asking whether we'll get such type of questions in the exam.
Yeah, definitely. This was a mock paper, and the final paper will be like that. If the question is in book test, that is the that means there is a probability that this kind of question can be in your quiz also. But see, the person told him, if you remember that property that if the line passing through the midpoint of the one of the line and it's parallel to another side, then it will cut to the midpoint again. So
Yes, ma'am.
and see this equation, to find the coordinates using this equation of line is not that much time consuming in this particular part, because it was actually really easy calculation. If you do by yourself, it's not that much tricky. I have to explain each and everything. That's why I was going slowly, like one by one. Otherwise, the calculation is like not that much difficult, I think. Was it? Sorry. Like, was it that much complicated?
Ma'am, by
Felt like
midpoint theorem, can you explain how to calculate G? Can you just
How to calculate
G, point G?
point G? Okay. Through this equation of line?
No. By midpoint theorem.
By midpoint theorem. So see, your point E. See, you know that O to alpha, O to D, the length is alpha, right? 0 to D, the length is alpha, and we know that the point, this F is nothing but alpha by 2 comma 0, right? That means F is your midpoint for this line 0 to D, isn't it? The OD, right? And
Yes.
it's going vertically upward, and so at a for the line AC, the point E is midpoint, right? Similarly,
Yes.
because it is parallel to OD, the line AC was parallel to OD. Fine. Now, your line EG is parallel to other side of triangle BC, right? This is the side of triangle, na?
Yes.
Triangle ABC.
Yes.
Just look at the triangle ABC. The line EG is parallel to BC. That
Yes.
means this line EG will intersect at a midpoint of your line AB.
Yes.
So again, you can draw one more line. Let's say it XY. Okay. XY. Fine.
Okay.
And let's say this point 0 comma beta is nothing but Z. So do you know what's the length for this point A to Z?
Ma'am.
It's beta by 2, right?
Yes.
That means your point X will be at beta by 2 divided by 2, beta by 4.
Yes.
Ma'am, I have to
X.
say something.
Yeah.
We don't need to calculate that part, ma'am. Actually, if we know that G is the midpoint of AB, then we can simply add the coordinate and half it. 0 plus alpha by 2 and beta by 2 plus beta by 2.
Sorry. Repeat again. 0 plus?
G is the midpoint of AB, ma'am, and we know the coordinate of A and B.
Yeah.
Then we can compute the coordinate of G. 0 plus alpha by 2, x1 plus x2 by 2,
yeah.
y1 plus by 2.
Average, yes. 0 plus alpha by 2 and beta by 2 plus beta by 2. Yes.
Yes, ma'am.
Yeah. Okay. Do you got, what was your name? So yeah, if you know, see, do you know this line, equation of line? If you know this point A, this point B, okay? You know the coordinates of A and B, let's say x1, y1. And coordinate of B, x2, y2, okay? Then if someone says this point C is a midpoint of A comma B, midpoint of A and B, then how will you calculate the coordinate for C?
Yes, ma'am, I understood.
Yeah, the same way he is calculating the coordinate for G.
Yes, ma'am.
Okay.
But ma'am, then it is coming to be.
Sorry?
Okay, got it.
Yeah, this is another way. See, these are the these are the things. If you remember this triangle law, then it becomes easy. But in case you do not, in that case, you just can go with this equation of line. Is it okay? Like if you are not confirmed with the midpoint things, then you can go with the equation of line also.
Ma'am, actually, I found that way easier.
Which one? Midpoint. Yeah, that's easy, because whenever you apply any argument or corollaries or theorems to any particular things, then the things will get easy only. That's why theorems and all these things are built in the mathematics to make the things easy. Okay, then, yeah, that was all for the mock discussion. All the best for your examinations.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
I hope it helped you. Okay.
Thank you,
Yes,
ma'am.
ma'am, it really did. Ma'am, so questions will be of the mock level in the exam.
Yeah.
Okay, thank you.
Like just consider +1 -1. Okay, that
Okay.
as variation.
Okay, ma'am.
Okay.